All right, Honors Algebra 2 and Algebra 2, welcome to your coronavirus quarantine video number 2 for your 7-1 to 7-4 game plan. This is talking about sections 7.3 and 7.4, logarithms and log functions. We did this in class in exponential form, 5 to the third equals 125. It's the same thing as saying log base 5 of 125 equals 3. That's the base, that's the answer, and that's the exponent. Log base 7 of 49 is 2. Log base 5 of 125 is -2. Log base 8 of 2 is 1/3. Log base 17 of 1 is 0. Log base 12 of 12 is 1. The goal is 8 to the 1/3 equals 2. 5 to the -2 is 1/25. So go from exponential to logarithmic. We did this. 3 to the 4th equals 81 is log base 3 of the answer 81 equals the exponent 4. Log base 5 of the answer 5th equals -1. Log base 100 of the answer 10 equals 1/2. Log base 1/4 of 16 is -2. Log base 10 of 1,000 is 3. Base 10 is the applied base. You can say log 1,000 equals 3 as well. Go from log to exponential form. That's 2 to the 4th is 16. 4 to the 3rd is 64. 81 to the 1/2 is 9. 3 to the -2 is a 9th. All right, so I honestly forgot what I had for 9 to cut off in Honors Algebra 2. So Algebra 2, if you don't have it, just write log base 5 of 625 equals x. That means 5 to the x is 625. 5 to what power gives you 625? Before. Right? Equals x for all of these. You're looking for that exponent. 2 to the x equals 32. X would be 5. 5 to the x is 125. X is 3. 4 to the x is 256. X is 4. 12 to the x equals 12. X is 1. X 7 to the x is 1. X is 0. 49 to the x is 7. Uh-oh. So if you guys know that the square root of 49 is 7, then you have your answer. 1/2. If not, we just talked about these, you got to write it as an exponential. 49 and 7 can both be written as base 7. 49 is 7 squared. 7 is 7 to the first. Got a power to a power. That is now 7 to the 2x equals 7 to the first. 2x would equal 1. X is 1/2. You might have to do that for some of these. 3 to the x is 243. Just got to, you can also make 243. That's 3 to the 5th. That's how we get 3 to the x equals 3 to the 5th. X is 5. 2 to the what power is an 8th? Well, if you know 2 to the 3rd is 8, then 2 to the -3rd is an 8th. 9 to the x is 3. Square root of 9 is 3, so x equals 1/2. As your answer, you can also make 9 into 3 squared. Power to a power, you multiply. 3 to the 2x equals 3 to the first. X is 1/2. 19, 17 to the x is 289. X is 2. 120, 1/5 to what power gives you 1/25? You're starting with a number less than 1, ending with a number less than 1. So notice how the 1s are the same in the numerator. In the numerator, just say 5 to what power gives you 125? That power is 3. 1/4 to what power gives you 64? Here's what we know. 4 to the 3rd is 64. Well, that's 1/4. 1/4 to the 3rd is 1/64. Okay, close. So 1/4 to the -3rd would be equal to 64. If you're starting with a number less than 1, ending with a number bigger than 1, you had to have used the negative power. 27 to what power gives you 3? Get 27 to be 3 to the 3rd. Do a power to a power. Multiply the powers. That's 3 to the 3x equals 3 to the first. 3x would have to be equal to 1. The exponents have to be the same. The 3rd root of 27 is 3. That's why 3rd works there. 4 is 2 squared. 32 is 2 to the 5th. That's how you get 2.5. And that last one is 3. 7 to the 3rd equals 343. All right, next page here, 7.4, solving log equations. We should have done these in Honors Algebra 2 and Algebra 2, I believe. So write them out as exponentials. 25 to the 1/2 is x. X is 5. Just write what they say, exponential form. 4 to the 3rd is x. X is 64. X to the 5th is 32. What to the 5th power is 32? X would have to be 2. 3 to the 4th is x. X would have to be 81. Getting writing these as exponentials. 2 to the 4th equals x. X is 16. 9 to the 3 over 2 equals x. So here's how I can do it by hand. Take the second root, or the square root of 9, which is 3, then do 3 to the 3rd, that's 27. 16 to the 5 over 2 equals x. You take the square root of 16, which is 4. 4 to the 5th is that. 8 to the 4/3 is x. Take the third root of 8, that's 2. 2 to the 4th is 16. 16 to the 3/4 is x. Take the 4th root of 16. 2. 2 to the 3rd is 8. All right, also look at number 6 for this one. X to the 3/2 is 27. Whoa. So to get rid of 3/2, you would raise both sides to the reciprocal of that, the 2/3. That would cancel out the powers here. That would be 6 over 6, which is 1. You get x to the 1st, which is your goal. Raise both sides to the 2/3, so do 27 to the 2/3. Take the third root of 27, which is 3. Square it, 9. 6 to what power is 1 over 36? If you know 6 squared is 36, then 6 to the -2nd is 1 over 36. You started with a number bigger than 1, ended with a number less than 1. You had to have used the negative power. 5 to what power gives you 125? X is 3. All right. Next page is for everybody. Folks, log base 2, log base 2. So those parentheses must be equal. Set them equal to each other. X is 7. 9 to the 1/2 power is 2x plus 1. That's just the square root of 9, which is 3. X is 1. X to the -2nd is 16. So if you raise something to a negative power and get a number bigger than 1, you had to start with a number less than 1. Again, if I know 4 squared is 16, okay. 4 to the -2nd is 1 over 16, okay. So that means a quarter to the -2. What did I say? Yeah, 4 to the -2nd. So a quarter to the -2nd is what we want, 16. So x is a quarter. That's a harder one for sure. 16, 3 to the 5th is 4x minus 11. Solve. 17, 5 squared is 3 minus x. We solve. And 18, 11 squared is x plus 7. We solve that. Now, 19 to 21, where these are definitely harder. Again, it's just like 13, log base 10, or log. So you set those two parentheses equal to each other. The only way to solve this is by getting everything to one side and factoring. When you have x squared in the middle term, you got to solve by factoring. What multiplies to 10 and adds to -7? -5, -2. You get x equals 2 and x equals 5. You get two solutions there, but got to remember, log of 0 is undefined, log of a negative number is undefined. So you got to plug in your solutions to one of those two logarithmic expressions, all right? So use that. Plug 2 in there, you get log of -4, which is undefined, so 2 is no good. Plug 5 in there, you get log of 5, which is good. So x equals 5 is the only true solution that is allowed. X equals 2 is called extraneous. 20 do the same thing, log base 2, so those two parentheses must be equal to each other. Set them equal to each other, move the negative x over, move the 2 over. So you got x squared plus x minus 2. Multiplies to 6, differs by 1, positive 3, -2. Get two answers of x equals -3 and x equals 2, and I forgot to check my answers. When you plug -3 in here, you get a positive 3 plus 2. Log base 2 of 5 is a winner. If you plug 2 in here, -2 plus 2 is 0. Log base 2 is 0, undefined. So x equals 2 is extraneous. Then I forgot to check my answers on 21 as well. Okay, log base 10, log base 10. Again, if there's no base there, it's implied 10. Anyway, the bases are the same. 3x plus 8 equals x squared plus x. Move everything over. 1 multiplies to 8, differs by 2. -4, positive 2. X equals 4x equals -2. Plug them in anywhere. If you plug -2 in, you get -6 plus 8, which is 2. Log of 2. Type it in, you get an answer. You get no domain error. Plug in 4. You get 12 plus 8. Log of 20. Also don't get a domain error. This is an example where both answers are correct. All right, the next page is Honors Algebra 2 only. We kind of talked about this already. This one's pretty easy, so just check your work. Check your work there. Get the bases to be the same. Not too bad. All right. Not too bad. There's the 8. And number 9. All right. The next page is Honors Algebra 2 only as well. Algebra 2, take a pause. Get some water, stay hydrated. All right, check your answers here. Pause anytime you need. Power to power, get the powers, multiply the powers together, get the bases to be the same, set the exponents equal to each other. 11 is the same thing as 18 for whatever reason. Everyone's on this. State whether it's exponential growth or decay. If the base is bigger than 1, it's growth. Move it over twice, that's 1.5% growth. Move it over twice, subtract it from 100, it's a decay, 14.3%. Move it over twice, 2.5% growth. Move it over twice, 51% growth. Move it over twice, subtract from 100, it's 2% decay. Move it over twice, subtract from 100, 12.5% decay. Move it over twice, subtract from 100, 7.5% decay. Move it over twice, subtract from 100, 0.2% decay. Move it over twice, it's 4.5% growth. Let's wait for that to adjust. There you go. And for everybody, the last page, you're just going to have to type this in your calculator or your app, or we'll just do it when we get back. 20,000, 8% yearly rate, 1.08, raise it to the 30th. Hopefully it's some good money. 42,500 times 1.03 to the 30th power, 30 raises. 100,000 times 1.028 to the 20th. A few classes did this. Now, if you're losing 3%, then that's basically 97%. It's the initial value every single year. That's Yogi making some noise. 0.97, raise it to the 15th, multiply it by 25,000. Folks, that concludes your 7-1 to 7-4 game plan. So that should be ready. We'll talk about it when you get back, and then the next day I'll probably take that from you. This is Yak Math Videos signing out.